Let us start. Once see at STP conditions, what is the temperature value? 273.15 or 273. Pressure is 1 atmosphere. Density of water is 1 gram per ml. 1 ml is equal to how many centimeter cube? 1 ml is equal to how many centimeter cube? 1 ml is equal to 1 centimeter cube. 10 ml is equal to 10 centimeter cube. Right? 1 liter is 1000 ml. 1000 ml or 1000 cc or 1000 centimeter cube. Clear? And the kg relation also given. Right? Let us start some basic questions. Right? If you are thorough in these basics, then you can understand the NEET level questions. These are also previous questions only, but basic, very easy level questions, and most of the time these questions were repeated in the NEET. First model question, after completing theory, we are doing first model question per NEET. Now done first question. Which of the following contains more number of or maximum number of atoms? 4 grams of helium, 2 grams of hydrogen, 4.4 grams of CO2, carbon dioxide. This is the question. See, these questions are basic level questions and repeated in NEET also. Easy questions only, easy level questions. Right. One important point you have to remember, if you say hydrogen means H2, oxygen means O2, nitrogen means N2, like that you have to take. Clear? First tell me number of atoms in helium. How many atoms are present in helium? See, helium is inert gas, right? Inert gas. It do not combine with any other atom. So atomicity is 1. Atomicity is 1. What is its atomicity? Atomicity of any helium gas is equal to 1. During the numericals, remember, helium do not combine with any other helium atom or any other, right? And what about hydrogen? Hydrogen means we have to consider it as a H2. Hydrogen, H2. So atomicity is equal to 2. Atomicity is 2. Clear? And CO2. Directly formula is given. So atomicity is equal to 3. Atomicity is 3. Right. For first option, let us calculate number of atoms. For option A, number of atoms is equal to atomicity into number of moles into Avogadro number. This is the formula. Number of atoms follow. You have to by heart. Clear? Okay. Atomicity for first option. Atomicity is 1. Inert gases atomicity is 1. 1 into number of moles. What is the formula for number of moles? Weight by gram molecular weight into Avogadro number. How much weight is given? 4 grams. 4 by what is gram molecular weight of helium? Helium gram molecular weight. Helium atomic number is 2. Atomic number is 2. Double the atomic number. Gram molecular weight or gram atomic weight. In case of monoatomic, we can consider gram atomic weight. Gram molecular weight or gram atomic weight in case of monoatomic. So 4 into Avogadro number. How much? Na. Avogadro number value is 6.023. So 1 Na. For first option, how many atoms are present? Na. 6.023 into 10 to the power of 23 atoms are present in the first option. Clear? Any confusion in this? In number of moles, we will write the formula weight by gram molecular weight. But this is monoatomic, na? For monoatomic gases can be considered as a molecules only. Inert gases can be considered as a molecule only, right? For first option, we got Na. Na molecules. And similarly, you tell me for second option, how many molecules are present in second option? Same formula, same formula. Right. Did you copy this? Copy. Online students, you also copy this. Have you copied? Have you? Second option, for second option. Calculate number of atoms per second. Atomicity H2, hydrogen is H2. 2 into number of moles. What is the formula? Weight by gram molecular weight. 2 by gram molecular weight of hydrogen. Hydrogen gram molecular weight. 2 only. 2. H2. H2. Hydrogen atomic weight is 1. 1 plus 1. 2. H2. And Avogadro number Na. So 2 will get cancelled. 2 Na. 2 Na. So for second option, how many atoms are present? 2 into Avogadro number. Compared to first option, this is having more number of atoms. Okay. Similarly, let us check for third option. Third option. First option Na. Second option 2 Na. For third option. Option C. Atomicity CO2 3 into number of moles, weight by molecular weight of carbon dioxide 44. I given already molecular weights of some important compounds and Na. Tell me here 4.4 by 44 means 1.1. 4.4 by 44. 0.1. 0.1. 0.1 into Na. So 0.3 Na. 0.3 Na. See, 1 Na which is greater value Na for first option. For this option we got Na. For this option we got 2 Na. For this option we got 3 Na. So which is greater? 2 Na. So answer is 2 Na. Second option. In second option, more number of atoms are present. Okay. Right. Let us see next question. Yes. Because see, mass of an atom, I given in the basics. Mass of an atom is expressed in AMU. Mass of one atom is expressed in AMU or U. AMU or U. Mass of oxygen is 16U. Mass or atomic mass, both are same. Mass or atomic mass. Atomic mass of carbon, same. Atomic mass is expressed in AMU only. 12U. U or AMU, both are same. So B is, where it is? Next, gram molecular weight of sulfuric acid, 98. 98. 1 gram atom of carbon. 1 gram atom is equal to, it's a gram atomic weight. 1 gram atom of any element is equal to, it's a gram atomic weight, 12 grams. 1 gram atom of any element is equal to its a gram atomic weight I given already. Remember now. 1 gram atom of any element is equal to its gram atomic weight. 1 gram atom of oxygen is equal to 16 grams. 1 gram atom of calcium is equal to 1 gram atom of calcium is equal to 40 grams. Okay, right. What is the answer finally? A, B, C, D, DT. Any doubt? BQ, where it is? Yes. CR. D, P. Basics, basic level. We also see the questions once again, okay? Without basics, you will get a problem in coming chapters. Chapters are concepts also even. atomic structure, equilibrium, ionic equilibrium, especially in thermodynamics, first year and second year solutions, we use these basics. Next question. The density of water is 1 gram per ml. The volume of the water drop is 18 ml. Sorry. The volume of the water drop is 18 ml. How many atoms are present in one water drop? We are doing number of atoms question, right? That's why given. At present we are doing number of atoms, number of molecules, na? So this is the question. Look at this. You tell me. When we calculate number of atoms, if we know weight, and gram molecular weight we know, that is fixed. So if we know the weight, then we can find the number of atoms. Then how to know the weight? One hint is given to you. 1 ml water weight is 1 gram. 1 ml water weight is 1 gram. 1.8 ml is 1.8 grams. For 1, 1. For 2, 2. For 1.8, 1.8. Over. Clear? So weight is given there only indirectly 1.8 grams. We know weight and we know gram molecular weight of water 18 grams. And atomicity H2O 3. Over. Clear? See this. Since density is equal to 1 gram per ml, means what is the meaning for this? 1 ml water weight is 1 gram. Then 1.8 ml, because volume of water drop is given to you. Volume of water, this is water drop. How much volume this is? 1.8 ml. In this water drop, how many atoms are present? We have to calculate that. Volume of water drop is given. Inside water drop, how many molecules are, how many atoms? Molecules are atoms, we can find anything. Clear? 1 ml weight is 1 gram. 1.8 ml weight is cross multiplication. Or you can say directly for 1, 1, for 2, 2, for 10, 10, for 1.8, 1.8. So weight is equal to, x is equal to, weight is equal to 1.8 grams. 1.8 grams. Okay? Right. We know weight, we know gram molecular weight. Water formula is H2O. So what is gram molecular weight and atomicity? Gram molecular weight is equal to 18 grams and atomicity is equal to, formula is H2O, na? So 3. Now use the formula. Number of atoms is equal to atomicity into number of moles into Avogadro number. Okay. Are you getting? Online students? Hello? Are you following? Number of atoms is equal to atomicity into same formula, number of moles into Avogadro number. Atomicity 3, H2O. Number of moles, weight by 1.8 beta into Na, Avogadro number. So how much we will get? 0.3 Na. You can expand Na. 6.023 into 10 power 23. Based on the given options, you have to expand, or you can keep like this only. How many moles of oxygen atoms are present in? .1 mole of CaCO3. 0.1 mole of CaCO3. What is the question? How many moles of oxygen atoms are present in 0. moles of CaCO3. That is the question. How many moles of oxygen atoms? Once look at this. Let us take one single molecule. Take one single molecule. In one molecule, see CaCO3. How many oxygen atoms are present? 3. In one single molecule, 3 atoms are present. 3 atoms of oxygen are present. Correct? Only in a single molecule. Single molecule contains 3 oxygen atoms. One single molecule. Right? No doubt. 2 molecules contain 2 molecules. 2 into 3. Correct? Only na? 3 molecules, 3 into 3, 4 molecules, 4 into 3, 5 molecules, 5 into 3. You are multiplying with 3. One molecule, one CaCO3 contains 3 atoms. 2 molecules contain 2 into 3. 3 molecules contains 3 into 3. 4 molecules contain 4 into 3. And so on, and so on. 6.023 into 10 to the power 23, that is equal to 1 mole of CaCO3 contains, guess how many? 3 into 6.023 into 10 to the power of 23 atoms. This is general explanation. Okay. 1 mole. Now let us see. 1 mole. 1 mole of CaCO3 contains how many atoms? These many atoms, right? And you tell me, just a second, wait. In place of 6.023 into 10 power 23, can I write a mole? Yes or no? Because this value represents a mole. So 3 moles of oxygen atoms in how many moles? 1 mole. 1 mole of CaCO3 contains 3 moles of oxygen atoms. Very important fundamental topic. Clear? You can write like this only. You have to prepare, okay? Listening one time is not sufficient. For stoichiometry, you have to do some working also. You have to observe what we wrote, what is the relation. So 1 mole of CaCO3 contains 3 moles of oxygen atoms. 3 moles of oxygen atoms. What is the question? 0.1 mole of CaCO3. Over na? For 1 mole, these many. For 0.1, do cross multiplication. Now coming to the question. This is generalized relation. Clear? Note down this. Okay, now coming to the question. 1 mole contains 3 moles of oxygen atoms. But in the question, how many moles are given to you? 0.1. Then do cross multiplication. See, 1 mole contains 3 moles. 0.1 mole of CaCO3. 0.1 mole of CaCO3 contains how many? Do cross multiplication. X into 1 is equal to 3 into this cross multiplication 0.1. That is equal to 0.3 moles of oxygen atoms.